All right, today we're going to talk about the difference between atoms and ions. And in here you see we got some chunks of sodium metal. And it's a very soft metal. You can see if I just kind of stab it with the scapula there, you can pick it up. So it's a very, very soft metal. And so I broke it up into pieces. But it's under oil right now because sodium metal, this is sodium metal atoms. They're very, very reactive, very dangerous because of how reactive they actually are. And the reason is because the sodium atoms have 11 protons in the nucleus and 11 electrons in their outer shell. They have no charge, which makes them an atom. But if you look at the levels that the electrons are in, it has 2 electrons in first level, 8 in the second level, and 1 in the third. And all the elements would love to have 8 electrons in their outer shell. The way they'll do that is gain or lose electrons from their outer shell to have 8. Because if it loses that outer shell electron, then it'll become very stable, and then it would become an ion because then it would have a charge because now it's got 1 more proton than electron. So when you're eating French fries, you're not eating sodium metal because that's very dangerous. The sodium chloride in your French fries is actually sodium ions, and we need sodium ions because it helps our muscles to function properly. Alright, so now I'm going to take this piece of sodium metal and we're going to put it in some water, and you can see how reactive it is when you do that. It's actually taking and pulling the hydrogens off the water molecules, and you get hydrogen gas that's being produced. Sometimes it'll produce enough energy that the hydrogen gas will actually catch on fire. And here's a larger piece of sodium.